So question 7 says form a polynomial with the real coefficients having the given degree and zeros. So notice how this is a degree 5, so that's kind of big. So one of the zeros is one of the zeros is 5. One of the zeros is negative I, so that means there's got to be a positive I present. And then we have a negative 7 plus I, that means there's got to be a negative 7 minus I present. So remember, to write them as factors, we have to use this x minus r concept. So if 5 is a 0, then we have x minus 5. If we have negative I, then we have to have x minus a negative I, which is going to be x plus I. And then if you have an I, that's going to just be x minus I. Then you're going to have x minus, again, we're going to have this negative 7 plus I. And we're going to have this x minus, and then you have this negative 7 minus I. So we have this x minus 5. We have this x plus I. Oops. So we have then this x plus I. We have this x minus I. And here we need to bring the subtraction sign through the parentheses to make that look a little bit easier. So it's going to be x plus 7 minus I. And then if we bring this subtraction sign through, we're going to have x plus 7 plus I. So as we do this, the first thing I would probably do is the x plus I and the x minus I. So the x minus 5 is going to come down. Again, since there's a difference of squares, you're going to have x times x is going to be x squared. And then the I times the negative I is going to be negative I squared. But remember, by definition, I squared is equal to a negative 1. So when I change this I squared to a negative 1, since there's already a subtraction sign there, that's going to turn that into actually a plus 1. Now, the rest of this looks a little more complicated, so I'm going to just bring it down for the time being. So the next thing I would do is probably multiply this 3 by 3. So I'm going to use a rectangle as an organizer. So we're going to have this x and this 7 and this negative I. We're going to have this x and this 7 and a positive I. So this is going to be a 3 by 3 partition. So x times x is going to be x squared. X times 7 would be 7x. X times I would be xi or ix. Usually the I would be the coefficient. 7 times x is 7x. 7 times 7 is 49. 7 times I is 7 times I. Negative I times x is going to be negative ix. Negative I times 7 is going to be negative 7i. And then negative I times I is going to be negative I squared, which means I squared is a negative 1, so that's actually going to make that a positive 1. So again, you had this negative I squared. But remember, I squared is a negative 1, and the opposite of a negative 1 is a positive 1. So that's going to probably be, can't really leave that there. So if we pay attention to this, we should now see that there's going to be an x squared here. 7x and 7x is going to give me a 14x. The ix and the ix zero out. The 7i and the negative 7i zero out. So all left there is a 49 plus 1, which is a 50. So what I have now is this x minus 5 times this x squared plus 1 times this. Again, I could probably use FOIL on this without having to use the box. So that's going to be x times x squared would be x to the third. X times 1 is 1x. Negative 5 times x squared is negative 5x squared. and negative 5 times 1 is negative 5. So then I have this x squared plus 14x plus 5. None of those are like terms, so it's a good idea to put it in the correct order, though. So I have x cubed minus 5x squared plus x minus 5 times then this x squared plus this 14x plus this 5. So since this is a 4 by 3, I'm going to go ahead and use the box again. Make a big old box. So I'm going to do the 3 on this side. X squared, 14x, and 5. X cubed, negative 5x squared, x, and a negative 5. So I'm going to partition this off here. So x squared times x to the third is x to the fifth. X squared times negative 5x squared is negative 5x to the fourth. X squared times x is x cubed. X squared times negative 5 is negative 5x squared. 14x times x cubed would be 14x to the fourth. 14x times negative 5, well, it's going to be a negative 70x to the third. They will double check that. Negative 5 times 14. Oops, negative 5 times 14. Negative 70, yeah. 14x times x would be 14x squared. And 14x times negative 5 again, this is going to just give me a negative 70x. 5 times x cubed is 5x cubed. Actually, that was a 50, not a 5, wasn't it? That was a 50. So I should add a 50 there. So 50 times x cubed should be 50x cubed. Fifty times negative 5x squared, that's going to be negative 250x squared. I'll double check that. Negative 5 times 2 times 50. Yeah. 50 times x is 50 times x, 50x, and then 50 times negative 5 would just be negative 250. So if we put this all together, the x to the fifth would come in. And then these have different signs. So that's going to be 11x to the fourth. So I have a 1. Those are all, so that's like different signs there would be a negative 20, negative 19 x cubed. So if we double check that, 50 minus 70 plus 1, negative 19. Then we have, so we have negative 250, lose 14 would be negative 236. And then add that, looks like negative 241 is what we're picking up on there. So negative 250 plus 14 minus the 5. So yeah, negative 241 x squared. And then negative 70x and 50x would be negative 20x. And then the minus the 250. So if I come up here, we're about to put that all in. So it looks like I kind of got too far away. So x to the fifth plus 11x to the fourth. Minus 19x cubed. Minus 241 x squared. Minus 20x. Minus then 250. That requires a lot of math. So that's kind of where we are with these problems. So if you have to watch that video again, feel free to do so. A lot going on.